This lesson's on constraints, and it's the second last thing that we need before we can completely solve these linear programming problems. Constraints are inequalities which describe a restriction on the values a variable or expression can take due to a limited amount of money, time, ingredients, material, or staff. The example we saw in the previous lesson was a limit on the number of adults and students that could attend the pool because there was a limited amount of money. We might be looking at how many of two different products we can make. We'll have limited time to make these products. Similarly with ingredients, be it different types of concrete or different types of flour, even in a cooking context, to be able to make two different products. Same thing with material, and same thing with the number of hours or staff that we have that people can work. Constraints combine the variables and parameters into an inequality, pretty much exactly like we did in the previous lesson. We're going to graph several constraints together to create a region of feasibility. Okay. So I'll look at a scenario. We're working for the Canterbury Cafe, preparing breakfast meals. Open the fridge and we see there's only 48 eggs in the fridge. If a scrambled eggs requires 2 eggs, but an omelette requires 3 eggs, how many omelettes and scrambled eggs could be made? So what are all the possible combinations that we could make? So if a big order comes in and they say, I want 20 scrambled eggs and 5 omelettes, we need to be able to look at this graph and see if we can make it. First of all, we'll identify the variables and parameters. Our variables are going to be the number of scrambled eggs and the number of omelettes that we can make. When I'm defining the variables, I've come into a little bit of a problem that I want to put an O here for the number of omelettes, but I'm not going to because it could be confused with the number 0. In that case, I'll choose any other letter, M for omelettes. They're my variables. In terms of parameters, I know that scrambled requires how many? 2 eggs. Omelette requires 3 eggs. And I also know that the number of eggs needs to be less than or equal to 48, because that's the maximum that I have in the fridge. Rewritten so we can actually read it. I need to write down some constraints. I know that the number of eggs needs to be less than or equal to 40. I also know that the number of eggs that are going to be used, I'm going to make S scrambled eggs, which will take 2 S eggs. I'm going to make M omelettes, which will require 3 M eggs. And now I can combine this different expression for number of eggs with the fact that the number of eggs has to be less than or equal to 48. So 2S plus 3M needs to be less than or equal to 48. So that's my main constraint. I do have another constraint. Okay. I need to ensure no negative numbers. The way I'm going to do this is I need to say that the number of scrambled eggs needs to be at least 0, greater than or equal to 0, and the number of omelettes needs to be at least 0, greater than or equal to 0. So I'm going to need to graph these 3 constraints, 1, 2, 3, on the same set of axes. The hard work is going to be graphing 2S plus 3M is less than or equal to 48, but we'll just use intercepts method for that. To sketch 2S plus 3M less than or equal to 48, I'll start by finding the S-axis and the M-axis intercepts. It should be getting repetitive by now. I know the S-axis intercepts occur at M equals 0, and the M-axis intercepts occur at S equals 0. I'm going to just put S as the horizontal and M as the vertical axis. You can do it any way you want. So go ahead, find the intercepts, plot them onto your graph, and draw the inequality. Before you go ahead and get your highlighter and color in this whole bottom section, we also need to consider these other two constraints that we have in the problem. These constraints that S needs to be greater than or equal to 0 and that M needs to be greater than or equal to 0. The first one, I'm looking at where S equals 0 and I'm drawing a vertical line. So it's on the same line as the axes. And this is S is greater than or equal to 0. And then I'll look at M is greater than or equal to 0. So I'll see where M is equal to 0 and I'll draw a line along this axis as well. M is greater than or equal to 0. So I can label all three of my inequalities. The combined result here is that I need to be less than this line, I need to be above this line, and I need to be above this line in these three directions. So what that really means is that I'm just coloring in this triangle. Because S is greater than 0 means I'm not allowed to color anywhere here. M is greater than 0 means I'm not allowed to color anywhere here. So when I go to shade below this inequality, I can only stop at these axes. So we'll color in that triangle completely. This part shaded in yellow is the region of feasibility, which shows all the possible combinations that could be made. So when I look at this, I see, well, the maximum number of scrambled eggs would be 24, the maximum number of omelettes would be 16. So answering this question, what combination of omelettes and scrambled eggs could be made with 48 eggs? I'd write between 0 and 24 scrambled eggs, and between 0 and 16 omelettes. And if I wanted to, I could also go ahead and just list some other random combinations. I could have 6 scrambled and 4 omelettes, for example. I could go around every single point that I can find in that feasible region and say, yep, I can make that combination. Here's a whole heap of similar questions for you to have a practice at. It's really important that we can draw these regions of feasibility without any dramas before we go on to the next lesson, which is objective functions.